So thank you everyone for coming. We're Brew Smart. My name's Alex Bonacum. This is Norman Riker and Liz Bishop, and we're going to tell you a little bit about the idea that we came up with over the last semester. So right now in California, there's about 120 million barrels of beer produced each year. And based off of a rough estimate of water to beer used and produced there, that's about 20 billion gallons of water used annually just to produce beer in California. And as of last year, Governor Jerry Brown passed Executive Order B2915, which required all of California to reduce their water consumption by 25%. And although agriculture is exempt from this, the brewing industry is not. And at about $0.002 per gallon to $0.008 per gallon, this comes out to being about $60 to $8 million a year in water consumption. And all of that needs to get reduced by about 25% to avoid some pretty hefty taxes that will be implemented this year. So our proposal is to redevelop and redesign some of these antiquated brewing practices that have been sort of just industry standards for the last 100, 200 years. Mainly focusing on the boiler kettle, which currently just vents steam that is produced throughout the 2-hour boil. Recycling some of the spent non-clear wort that's lost through the whirlpool stage, and using a condenser to basically just recondense all this captured steam and recycle it into further processes down the road. There's the potential to reach as high as 70% if we address a couple extra stages, but right now we're just trying to get our foot in the door. So we're doing some very basic stuff here that'll hit the 25% necessary, and then down the road we plan on also continuing to work as a consultant firm and looking into things like electrochemical processes that might be able to remediate even more of that water that's lost, especially during the sparging process.
So like Alex said, our focus right now is on the California brewing system, and that's mostly because California sells or produces the vast majority of beer in the industry. And these are numbers from 2015 based off of the statistics over the past year. As you can see, there's been a trend line of number of breweries increasing over the past couple of years, and it's predicted that this trend line is going to increase and that more breweries are going to come into the market to produce more beer, which means that more breweries are going to be looking ways to save water and save money due to the California regulations. And then here is just a small map of breweries in Northern California that are open right now. We are planning to centralize ourselves in Stockton, California. And as you can see, all those dots around are currently breweries, and many of which are looking into recycling water and saving water in their brewing process. And California has 9 of the top 50 breweries in Northern California specifically. So what our plan of attack would be to consult with these top 9 and any other microbrewing that we're looking into recycling process. Specifically these top 9 just because they're in the central location and they are large factories. And then this is just a SWOT analysis of our total marketing strategy. For those who don't know, SWOT stands for Strengths, Weaknesses, Opportunities, and Threats. Basically, our strengths include just having like a simple idea compared to other ways that you could save water in the brewing process. Our location is really centralized around several dozen breweries, and our customer price versus savings is competitive, and we're just an environmentally ethical company. And then mostly our strengths are just outweighing the opportunity, or our strengths and weaknesses outweigh, strengths and opportunities outweigh our weaknesses and threats.
So there are some competitors already out in California, like Alex said, with the new tax laws. They're trying to get a head start on this. Half Moon Bay is pretty interesting because their idea they're not trying to market yet. So what they introduced last year at a sustainability conference in the Bay Area was this Maverick Tunnel Vision IPA. And what they did is they used NASA technology that was used on the International Space Shuttle to reuse wastewater. And these are the 2 beers that they have. This is the regular one, and this is the made with wastewater. And they did a blind taste test, and people that drank it could not tell the difference. Like I said, so far they're only used for samples just to show how you can use wastewater and it won't affect the quality of the beer. And they said they're not trying to market it, and they're just trying to get policymakers' attentions to change the laws so they will be able to market it and change the industry in general. Our main competitor is Cambrian Innovation. They've already they've created this EcoVolt reactor, and they've established it at Lagunitas and Bear Republic, both in Sonoma County. This treats wastewater using electromethanogenesis, and it basically scrubs off pollutants and is able to scrub off about 90% of those pollutants. And it creates methane gas, which can be then used for the electricity in the factory. And it also is able to scrub off pollutants to reuse the water. Before they set up these reactors, they were shipping 50,000 gallons a day, about 40 miles using a truck to treat the wastewater. So again, they're not only saving water, they're saving money by shipping it and decreasing their carbon footprint by not using those trucks and doing it all on site.
The obvious two main disadvantages with both of those approaches, one being it's currently not allowed by the California State Legislature to produce beer and at the the industry level with wastewater that isn't properly treated, and the EcoVolt is extremely expensive. A lot of microbreweries aren't going to be able to use this kind of technology just from a financial standpoint. So that's sort of the market that we're trying to address as well.
So basically, you see our competitors and you want to know why you would choose Brew Smart. Like Alex and Norm both pointed out, we're substantially less expensive than the EcoVolt and other competitors. Our process is pretty basic, so we only bring in like 5 additional pieces of equipment on site. Whereas the EcoVolt, you have an entire
Apparatus
like,
process. I mean,
it's like a big
it's a whole new
process
It's
that you have to ship
treated
in.
It's a whole new facility that you have to add on site.
Whereas our process, you can just add it onto your pre-existing brewery. Basically, you can save 25% recycling water, and this avoids the taxes and reduces your utility costs. Based off of a 10 million barrel a year production, you can be estimated to save about $5 million in just your utility costs. And in addition, Brew Smart plans to sell the grain that is dried during our process from the leftover wort and grains, and this could bring in potentially an upmost of $1.5 million in profit.
So now we'll go a little bit into the technical design. Again, like we've already mentioned, it's really basic, and that's why we think that this kind of idea would be easily implemented. Typically, in your brewing process, it goes to the boiler for about 2 hours, after which it gets sent to a whirlpool, spun around at about 15 feet per second to centralize all the grains, hops, and shrub, and then is sent out for further processing. As of right now, most places just vent steam. So again, all we're doing is making a slight modification to the boiler to then send that to a condenser. And at the end of the whirlpool phase, there's depending on your process size, a decent amount of the grain, the shrub, a little bit of the yeast that wasn't able to get fully separated from the water, and so you have wasted water that is in with those grains that usually just gets sent out as a waste product. But we're planning on pumping that to a secondary, much smaller boiler kettle to basically bake off or boil off the rest of the water, dry out the grains, and then barrel those to sell to the numerous animal feed distributors that are in California. And so again, it's really not that complex of an idea and very easily implementable for just about any brewery of any size. This is the process flow diagram. It basically just it's the summary of exactly what I just spoke about. Not really anything more to touch on other than, again, it doesn't take up a lot of room and it's only a couple extra pieces of equipment that we're implementing.
So this is our key equipment that we'd be adding onto the side of the brewery. Specifically, it's a centrifugal pump, an additional boiling kettle, condenser, storage tank, and piping connections. So altogether, you have like 4 large pieces of equipment that you'd be adding onto your site. But in general, our plan is to get these in bulk order from certain vendors, in order to work with certain vendors and reduce the price for our customers. And this will reduce the equipment price and keep our costs low so that we can be competitive with the EcoVolt.
The only real sizable piece of equipment too is this storage tank. We're thinking, 20,000 gallons perhaps would be a good size, just to make sure that at any time we have enough room to capture all the water that we're recycling. But that could be put outside of a facility. We could work with industrial engineers to make sure that we're within code on placement for that tank, stuff like that. But all these other pieces of equipment are no bigger than your typical pump or shell and tube condenser. So spatial restrictions are not something that we're too worried about. In terms of more specifics on some of these pieces of equipment, in terms of the boiler modification, as of what we were able to find, typical vents were between 10 and 18 inches. So for doing an economic analysis, we obviously went with the 18 just to say that we could hit the higher end if we had to. We'd just be using 18-inch stainless steel piping and connections to vent the steam from the boiler into a central steam line that would then get sent to the condenser. We're probably going to be looking to work with Honda to, again, purchase in large quantity the Honda GX centrifugal trash pump, capable of pumping 280 gallons per minute, even with the grain size that we're looking at. And that's obviously a huge benefit. That's way higher than it really needs to be, because usually there's almost a day in between potential processes at some of these larger ones, and even longer between processes or batches, I should say, at some of the microbrews. In terms of the kettles, you have two options here. We want to be able to work with our customers as much as possible to figure out what their needs and wants are. You could go for a natural gas kettle or an electric one. They obviously have varying financial and carbon footprint impacts. The electric one would take longer to boil off the water from the remaining whirlpool contents. So that might be something that you need to consider if we're looking at a larger facility. But if it's more about the eco footprint or the financial feasibility, we would work with our customers to make sure they're getting what they want. Any kind of shell and tube condenser would work. The one that we were looking at was the standard exchange. Based off of its heat transfer properties, if you were to put anywhere from 2 to 10 of them in parallel or series, depending again on the throughput that's occurring there, there are some safety concerns in putting 10 heat exchangers in series. It has to do with back pressure and stuff like that. But we would work with each customer individually to see how many of those condensers we would need to meet the time demands that they have in between batches. And connecting all this, we'd probably just be using anywhere from 1 to 3 inch EVA or stainless steel piping and hosing. Pretty cheap, reliable within the industry standard, and will fit just about everything that we have here in terms of equipment specifications. The only piece of equipment that we're sort of up in the air on is the storage tank. We would work with our customer to determine how large they would possibly need for a tank. It's also an opportunity, since it is just going to be storing water, to go on the cheaper side and look for used tanks. Working with our customers to make sure that they're getting the quality of equipment is obviously something we'll also take into account. Some microbreweries might be more acceptable of buying used equipment, whereas some of the larger facilities are going to want brand new, fully warranted equipment. So we're going to be working on a case-by-case scenario for that kind of stuff.
So this is just our equipment sizing and costs. Most of these were taken from the book that we were provided with. And based off of your sizing factors, we came up with a rough estimate of costs. Again, these could be lower based off of working with specific vendors and trying to do bulk pricing, because we will be providing these equipments to our individual customers. So we'll be purchasing it for them, and then we'll have a large lump sum for our overall cost to the customer. And this is just a quick process stream table of the amount of water that you would be able to save based off of your feeds. And your water to grain ratio is based off of the average of 1.5 quarts to 1 pound and your recycled flow rate is based off of the 25% percent of water you'd save.
So for our economic analysis, first I'll go into the capital costs. Our ISBL capital cost, which is inside battery limit, we don't have that much on site for us because we go to different breweries and facilities. So that we calculated by the amount, we were thinking about getting a company car as well as averaging the amount of money we spend on gas throughout the course of a year. And also one of the properties we found in Stockton, which was $200,000. So that is that estimate. Our OSBL, we calculated from the book from 40% of our ISBL. And our engineering costs was again from the book at 25% of the sum of ISBL and OSBL. And our contingency at 10% of our OSBL and ISBL, which brings us to our total fixed capital cost of $400,000.
We're obviously pretty excited about that. We sort of have a good opportunity here to get initial funding because the initial money to start this company up would be so small. All we're really doing is purchasing equipment from other companies and working with the technicians and engineers that are already on site at these breweries to implement these changes. So like Norm pointed out, very cheap to start, and from there it's all downhill. But
all right, so looking at our revenue, our product that we're selling is our consulting fee with the piece of equipment that they talked about. So we did some research on typical engineering consulting fees, and it ranged between $180 and $290 per hour per person. So we found a nice middle ground at $220 per hour per person with us three as our consultants. And that's where you get the price per unit. It is the sum of the raw materials cost as well as the consulting fees. We're aiming to install 20 units per year. We figure we'll spend about 10 days working at each facility. That includes time to go there, check out the space, make sure there aren't any safety hazards, and get an idea of the layout and how we can work with them to set up an effective process, the installation time, and then training whoever will be working on it so they are prepared to handle any safety hazards or anything that will come up. We don't have any utilities fees because we're working with them, so it'll be their utilities cost. So our variable cost of production is just our raw materials cost that you saw before. For fixed operating costs, we're working on labor, maintenance, and overhead expense. For labor, it will be just us three again, and we decided on a salary of $80,000 a year. The supervision, 25% of that, and then direct overhead, 45% of the supervision and the salary for each person. Maintenance was calculated as 3% of ISBL investment, and overhead was 65% of the labor and maintenance costs, and in tax and insurance, 2% of the fixed investment. So if you look at our summary here, you can see our profit is around $300,000 per year. Not that high, but again, with the risk that we're going into it, with only spending $400,000, our profit being a $300,000 difference is pretty good. And we're looking at, maybe depending how the first year goes, ordering more units, and once we get our name out there, we could extend to more breweries in the future. So for our environmental health and safety analysis, again, we're bringing in no new chemicals to the process since it's all mechanical. So the things that are in this part of the process is just water, the hops, and the isohumulone, which is the chemical released when you boil the hops. Again, all the people that will be working on this are already used to working on this every day. We're just changing the process a little bit. And as you can see, none of this is really harmful to human use.
we did FMEA on our process just to try to take a look at any of the potential safety concerns that would be associated with these changes, and here are a couple of the big ones. For the condenser, again, it's a piece of equipment that just about any engineer will feel comfortable using and implementing on their facility, but there obviously is a risk of something like overpressurization, your typical things that occur when you don't properly maintain or keep up your equipment, blocked inlets and outlet valves, etc. And that really just comes down to, again, properly training and detailing how to handle this equipment with the people on site over those 10 days that Norm was discussing. Having a couple fail open switch valves just in case there is a pressure buildup, pressure gauges, process control, stuff that we're obviously, again, all familiar with as engineers. In terms of the pump, kind of the same deal. We will be pumping grains and hops and shrub, and the Honda GX is suitable to handling that grain size, that particle size that'll be going through, especially since it is a trash pump, and is actually more fit for larger and less uniform materials. But obviously there is still a danger of those building up in the system, of the pump shutoff not working properly, and it pumping too much of that into the secondary 100-gallon boiler, in which case, again, it's a level controller, it's process control, it's properly training the people on site to making sure that they're checking out this equipment and maintaining it properly, and we're not too concerned about that one as well. The only real true danger to the employees would be, again, if the pump fills up the boiler too high, we have a buildup of pressure in there, and that could cause an explosive-like event. Again, it's process control. It's a steam release valve. If it hits a certain pressure, we would obviously then lose a little bit of the product, the water, but we're not too concerned about it. It's a piece of equipment that's already used in the brewing industry on a much larger scale. So implementing a smaller boiling kettle is going to be something that they're all very comfortable with and will most likely not have any issues with. All this equipment together, there's obviously new trip, slip hazards. That's just basic EH&S signage, training employees on the spatial awareness, and working with an industrial engineer potentially to make sure that we're setting this up as spatially, considerate as possible, and making sure that all the employees that work in the facility are aware of those dangers. So, in summary, based off of what we're proposing, we will be able to save just about any brewery 25% of their water for recycling and reuse. We're focusing again on the boiling and whirlpool stages, but would be very willing as a consulting firm to start working in other areas of the brewery to try to address further stages and get them more saved costs. We just again want to address the 25% immediately because of those California taxes that are being imposed. And even potentially, once we do make a name for ourselves, we can start working in other states as well. Because even though they don't receive the taxes that California will, there are plenty of large-scale breweries that would be more than happy to save $5 million a year on their water costs. We also plan on addressing down the road packaging and bottling. These are other areas of the brewing process that result in a lot of wasted water. Even just from the cardboard, the pulping of the cardboard that is used for a lot of these containers, stuff like that. As a consulting firm, we plan to address all of these as we continue to, make enough profit that we can start looking into this other stuff and implementing it again with the breweries that we've already been partnered with. And with installation costs and general maintenance costs of only $125,000 per process, even some of these smaller breweries which aren't using using $15 million a year in water costs, instead of making their profits back in the first year, some of these microbreweries might take 10 to 15 years to make their money back in water costs, but that's even before, again, the taxes, which if they weren't to implement these changes, they would still be using more water and they would be receiving those taxes. So obviously it's fiscally and environmentally responsible for them to hop on board.
So a couple recommendations moving forward. We plan to start with smaller breweries that Alex said wouldn't be able to afford an EcoVolt from Cambrian Innovation and might not even think about their profits in 10 to 15 years. But if we go in there and influence them to move to saving some water, they will be able to save a lot of money in the long run. That will help make a reputation for ourselves and move on to larger and larger breweries, maybe extend more into Southern California as well. We plan to grow as sustainable consulting, work with breweries on their individual sustainability goals. We also plan on hiring more consultants if we need to when we move on to more and more breweries. And we plan to look into other parts of the brewing process. We started with this part because it is where you lose the most water, but there's a bunch of water used in packaging with cleaning all the bottles, cleaning all the cans, and then bottling and energy consumption.
And lastly, we just want to extend our thanks and acknowledgments to Northeastern as a whole in the chemical engineering department, but specifically our mentor for Capstone, Joe Govoni, and our Capstone professor is Dr. Webster and Dr. ChE.
Okay, any questions? Apologize for not telling you to begin.
It's totally fine.
Okay, I guess that means you're relieved of any questions from me. You can ask the other, but I have some challenge.
They mentioned.
I'll give you a break here. They mentioned it even as I'm going on.
Yeah, they said, you know,
You had some good
be
questions.
prepared for questions. We were ready.
We don't need them.
Yeah. We're okay with no questions
No,
as
are
well.
there any questions from the students? Let me see how we're doing on time. We've got 4 minutes roughly. Don't sit down yet.
Let's close it up
We
quick.
can just stand here.
Maybe you could explain, I think you had your safety analysis up there briefly.
Yeah.
Let's go back to that slide and do some discussion about that.
The FMEA specifically?
Yeah, that's one, that's a good one. So explain to the freshmen here where'd you come up with this? Where'd you hear about PEA and?
I've done a failure modes and effects analysis at my co-op. They're typically a lot more in detail and in depth than this. I think the one that I was doing had probably 96 items on it, and this is obviously only 6, but I can't stand up here and talk about 96 things for a full 2 hours. Basically, it just looks at every single piece of the process. You can also do a DFMEA, which would be like a design failure modes effects analysis. That's more applicable to what I was doing, working on medical devices. But it looks at each piece, it identifies all the different possible ways that it can fail, and then it sort of a little bit arbitrarily, but through working with your team and safety oriented people, you get assigned an SOD, which is a severity, occurrence, and detection rate. With the higher the SOD being, more worried about that specific failure. And so for like a 48 versus a 96, typically when I was working, I think anything less than a 72 required no remediation. But once you hit that breach, you start looking at real like health and safety concerns, and that's when you might need to add an extra piece of equipment that just addresses safety, or you might have to run 20 different batches and validate that this is safe to use, and that's a whole process just validating that aspect or that piece of equipment. And again, it could be a lot more in-depth than
Explain
this.
the S on there, that goes from 0 to 10 or 0 to 100 or?
0 to 12, I believe.
0 to 12, and is there a table that gives you guidance?
There is. You can.
assign 8 to this one because of what and what?
So it has to do with, occurrence is the easiest one to describe. In terms of the table, it talks about, is there a 1 in 10 chance of this happening, a 1 in 100 chance, a 1 in 1,000, whatever that might be, it obviously branches out. And that all has a different occurrence rating. For severity, it's more like, if it's a 1, like it's not going to hurt anyone. If it happens, the equipment doesn't break, nothing really bad happens. Whereas a 12 would be, if this fails, if this failure mode occurs, someone could be really injured. Your equipment could be completely destroyed. The collateral aspect of it. And then detection is a little bit more, again, arbitrary. Is it detectable? Do you have these things like pressure gauges that would allow you to monitor it?
Less, more difficult to detect, or higher the number?
One is easily detectable. The goal is to have the lowest SOD possible. So
And then is that the multiplier of those 3?
multiplier of the 3.
8 times 2 times 3 is 48. Is that what you're saying?
I hope I did my math right.
Now, the one I'm missing is 8 times 3 times 4 is, let's see here.
12 times 8.
There's
I did that right?
6.
Am I good, guys? Check my math.
You're good.
Thank you.
And the other one is 8
I
times
didn't use a calculator, so I was worried.
You did it.
I don't know.
Specifically towards Northeastern curriculum, I think we learned this in Design 1, so I think.
It's in our book.
Okay. Well, this is the next group anxious to come in the aisle. All right. Any other questions? That was a very, very good answer, by the way.
Thank you.
I will say tell the other group you gave a very good answer. All right. See you later.
All right.
Thank you.